Hi, Assalamualaikum warahmatullahi wabarakatuh, and a very good evening to all of you students. Today, in our MAE503 Educational Statistic 2, we will learn about 3.2.3, that is confidence interval for population. So, for a confidence interval for population variance, suppose that we are sampling and the number of independent observation from a normally distributed population with a variance sigma squared. So this is the sample variance. The formula for calculate the sample variance is S squared equal to total xi, the number of observation, minus mean squared over n minus 1. So this is the sample variance. So we start with the population variance. The sampling distribution of the sample variance S squared is not normal. So how to calculate the population variance? So in the test statistic, we use chi-squared. Chi-squared of W is equal to n minus 1 times S squared, the sample variance, divided by the population variance. So W is a chi-square that have a degree of freedom n minus 1. In a test statistic, we cannot calculate it right away with the population variance. We have to find it from a sample. So from a sample, we have chi-square 1 minus alpha over 2 less than n minus 1 S squared divided by sigma squared is the chi-square less than the chi-square A alpha over 2. And this value we can find in the chi-square table. As we know that we want to find the population variance, that is sigma squared. From a sample that we have here, we just isolating the sigma squared into this equation. So what we have here is n minus 1 x squared divided by chi-squared alpha over 2 less than the population variance n minus 1 S squared divided by chi-squared 1 minus alpha over 2. So when we summarize 1 minus alpha, so we will get n minus 1 S squared divided by chi-squared alpha over 2, and we have n minus 1 S squared chi-squared 1 minus alpha. So let's get started for example 1. A sample of 7 boxes of a certain type of cereal with a weight 750 grams had the following weight. So this is the weight. So find a 95% confidence interval for population variance. So in this question, we only have a 7 sample here. So first, if we get this question, we have to find the mean for this population sample. So from the mean, we're going to have 775 plus 780 plus 781 plus 795 plus 803 plus 810, and the last one 823 divided the number of observation is equal to 7. So we have to calculate it, and after we calculate it, we will get 795.3 grams. We already find the mean. So now we will find the sample variance. So how to calculate the sample variance? Sample variance is equal to total number of xi minus mean square over n minus 1. So we actually can calculate this thing in a calculator, or we can find it one by one. So the sample variance is 351.5714 grams squared. So this is the sample variance. So after we find the mean and the sample variance, we're going to have to find what what is the confidence interval for a population variance? So the formula that we use is n minus 1 s squared divided by chi squared alpha over 2 and n minus 1 s squared chi squared 1 alpha minus 2. We want to find the chi-square table. So before we find chi-square table, I will show you how to calculate the chi-square, the x-squared value. So from this portion, we have alpha over 2. So from the equation, we know that we want to find alpha is equal to 100 minus 95%. So 95% is over 100. What we have here is equal to 0.05. So we want to calculate the alpha over 2. So 0.05 divided by 2 is equal to 0.025. So the chi-square table, we want to find the value of alpha over 2. The confidence interval is 0.025. So what we have here is we want to find 0.025 chi-square table, and the degree of freedom, don't forget the degree of freedom that we have in this example is 7 minus 1. So equal to, so as we have calculated the chi-square for alpha over 2, we need to calculate another portion, that is 1 minus alpha over 2. So what is the formula to calculate the alpha over 2 is the same as to calculate the alpha over 2 here. So what we have here is chi-square is equal to 1 alpha over 2 that we already calculate here is 0.025. So 1 minus 0.025, we will get 0.975. So chi-square table that we need to find for the another portion is 0.975. The degree of freedom, don't forget the degree of freedom, 7 minus 1 is equal to 6. So we will calculate from the table of a chi-square. From a table chi-square, the value for 0.025, the degree of freedom 6, is equal to 14.495. So this is the value from the chi-square table. And for the value of 0.975, the degree of freedom of 6 is equal to 1.2373. 1.2373. So this is 14.494. So we already find the value of chi-square for 0.025, degree of freedom 6, that is 14.494, and the other one is 1.2373. So what's next? We will just insert this table or this value into this equation. So what we have here is n minus 1. Our number of observation is 7 minus 1. Multiply with s squared. We're going to have s squared here. 351.5714 squared. It is advisable to have 4 decimal places. And the chi-square table that we have here, alpha over 2 is 14.494. The other one is n minus 1, 7 minus 1. The sample variance is equal to 351.5714. Oh, we don't have to square because of we already squared the sample variance here. We just multiply, divided by the value of the chi-square that we have here is 1.2373. So the answer that we have calculated is 131.04 and 1530.24. As a conclusion, we know that the answer is 131.05. This is the lower boundary to the 1530.25 upper boundary. As a conclusion, we can be 95% confident that the population variance or the true variance weight of the cereal in boxes of this type lies between 1.04 gram and 1530.25